In order to find all 6 of these trig functions, we're going to need SOH CAH TOA. Now, every letter stands for part of our trig ratios. Starting with the S, the C, and the T, those stand for sine, cosine, and tangent. This is the best way to remember your trig functions. Now, the O, the H, and the A are all about the sides of the triangle relative to angle theta. So whatever angle you're looking at, O is the side opposite from theta. A is the side right next to theta, so that's our adjacent, and then H is for our hypotenuse. Now we're going to start with sine and cosecant because they go together. That SOH tells us that the sine of theta is equal to opposite for O over hypotenuse for H. So I go and find that angle theta that I'm taking the sine of, and I want the side opposite, which is 4, and I want the hypotenuse, which is 5. So I put that together and I end up with opposite 4 over hypotenuse, which is 5. Now I can also find our cosecant. Cosecant is the reciprocal, so I'm going to end up flipping what I've got. So the cosecant of theta is equal to 1 over the sine of theta. This means reciprocal, so I really want hypotenuse over opposite. So that tells me that the cosecant of theta, I can actually just take what I found for the sine and take its reciprocal, and that's going to be a 5/4. Next up is cosine, and cosine is adjacent over hypotenuse. So we say the cosine of theta is adjacent over hypotenuse. I find that angle theta adjacent is 3, and my hypotenuse again is 5. So the trig ratio that I get here is 3 over 5. Now I also want to find secant, and I know that secant of theta, and this is something that you're just going to need to memorize, is the reciprocal of cosine. So I can go ahead and take its reciprocal. It is hypotenuse over adjacent, but I really just want to reciprocate what I got previously, and I end up with secant is equal to 5/3, and that cosine was a 3/5. Last up is tangent and cotangent. Now it tells me that tangent is OA, so the tan of theta is going to be opposite over adjacent. Back to our angle theta, opposite is 4 and adjacent is 3. So for tangent, I end up with a 4 over 3. Now from here, you can probably guess what we're going to do next. I want to take the cotangent of theta, and that's going to be the reciprocal of tangent. So I could do adjacent over opposite, or I can reciprocate what I got up above, and I end up with a cotangent of 3 over 4. This gives me all 6 of those trig functions. We're going to use that same triangle, but this time we're going to use that upper angle alpha to find our 6 trig functions. I do want to start with the sine. So the sine of alpha is equal to, this is still going to be opposite over hypotenuse. But now I want to find opposite angle alpha. Opposite side is 3, and my hypotenuse is still 5. So I end up with a 3 over 5. Let's also do cosecant here because it's the reciprocal of sine, which means that we're going to get a 5/3. Next is our cosine, and the cosine of alpha is adjacent over hypotenuse. This time the side adjacent to alpha is 4, so that's my adjacent side. My hypotenuse is still that 5, and I get 4 over 5. Now I also want secant, and secant is its reciprocal. So the secant of alpha is the reciprocal of cosine. I'm just going to flip that, and I end up with a 5/4. Finally, we want tangent and cotangent. I'm going to go ahead and start with tangent, and I know that the tan of alpha is OA, so that's going to be opposite over adjacent. For angle alpha, opposite is 3 and adjacent is 4. So we end up with a 3/4. Now we can also from here really easily get to our cotangent. And the cotangent of alpha is its reciprocal, which is going to be a 4/3. Next, let's use trig functions to find the length of a missing side. Let's go ahead and start with that yellow triangle. In that yellow triangle, I've got my angle 22.6. I have the side adjacent, which is 5, and I've got the side opposite. That's the one I'm looking for, which is x. So I can put opposite and adjacent together, SOH CAH TOA using tangent. So I've got the tan of my angle 22.6 is equal to opposite over adjacent. But I can replace each of those with their values from my triangle. So I know that my opposite side is x and my adjacent side is equal to 5. Well, I'm solving for x, so I want to isolate that. I'm going to go ahead and multiply by 5, and I end up with 5 times the tangent of 22.6 degrees is equal to x. Let's put this into the TI-84 so that we can get a number for it. Let's first make sure that you are in degrees. Go to your mode and then arrow down, and you'll see on mine I've got radians highlighted. I really want degrees highlighted. I'm just 4 rows down. So I'm arrowed over so that my cursor is blinking on degree, and then I hit enter. So now my calculator is ready to use degrees. Let's go ahead and quit here, and I'm going to type in exactly what I've got there. So I've got 5 times the tangent is right here, of 22.6 degrees. You can close the parenthesis or you could just leave that, and we end up with about 2.08. So we can say that x is approximately 2.08. Let's do that other triangle next. In our other triangle, we've got a 40-degree angle. We have the side opposite, which is equal to 2, and we've got that hypotenuse, which is equal to x. So I've got the O and the H, so I definitely want to use a sign here. So I can say that the sine of 40 degrees is equal to opposite over hypotenuse, but I know what those values are relative to my triangle. Opposite is 2, and my hypotenuse is that x that I'm solving for. I'm going to go ahead and multiply both sides by that x. As I multiply by x, I get x times the sine of 40 degrees is equal to 2. But x is what I wanted to isolate, so I'm going to divide both sides by the sine of 40 degrees. Sine of 40 degrees. So I end up with just the x left, and x is equal to 2 divided by the sine of 40. Let's go back to the calculator. I'm still in degrees. I'll type in 2 divided by the sine, which is above the 7, of 40 degrees. And I'm just going to type in 40 parentheses and then enter, and we get about 3.11. So x is approximately 3.11. Now we want to find that missing angle. I've got 2 examples here. Let's go ahead and start with that green triangle. And with that green triangle, I again want to identify what sides I have relative to my angle theta. So this time I've got the adjacent side and I have the opposite side. I do not have the hypotenuse. So I want to use SOH CAH TOA. I want to use tangent. So I can say that the tan of theta is equal to, it's going to be opposite over adjacent. So that will be 5/8. Now I want to get theta all by itself, so I need to apply its inverse function, which is tan inverse. Here's what it looks like. I'm going to write a little bit smaller. So tan inverse of the tangent of theta. In this case, I can cross off the tangent and the tan theta. They undo one another. I'm left with just theta is equal to tan inverse of 5/8. So we have just theta on the left is equal to the tan inverse of 5/8. Now my calculator is still in degrees, so I can go ahead and go back to my calculator. Let's type this in. I want the tan inverse, which is the second function on tangent. I'm going to hit that second button first and then tan inverse. Then I want my trig ratio, which is 5 divided by 8. I'm going to get that angle measure back, and that angle measure is about 32 degrees. So theta is about 32 degrees. Let's do the same thing for that pink triangle. In that pink triangle, we are given all 3 of our sides, which means that I can use any of the trig functions that I want. How about, I'm going to pick up the opposite side, and I'm going to pick up the hypotenuse this time. But I could have used tangent, I could have used cosine, but instead I'm using SOH CAH TOA. This is going to be my sine. So I know that the sine of the angle that I'm looking for is equal to opposite over hypotenuse, but I've got my opposite and I've got my hypotenuse. Let's put those in here. My opposite is an 8 and my hypotenuse is a 10. Just like we had done with the one previous, I want to apply its inverse function. So the sine inverse of the sine of theta is equal to, I apply sine inverse on the other side as well. So whatever I do to one side, I do to the other. On the left-hand side, the sine inverse in this case undoes the sine. I get my theta back. On the other side, I'm left with the sine inverse of 8/10. Let's put this into our calculator. Again, I want to make sure I'm still in degrees, and I know that I am. Sine inverse is the second function of sine. So I'm going to go second sine inverse, and then 8 divided by 10. And I end up with my angle measure, which is about 53 degrees. So theta is about 53 degrees. Keep up the great work. More trig videos here.